Welcome to the second of 13 SPSS video tutorials accompanying the first edition of the text Introduction to Statistics for Social Sciences. In this tutorial, we will be using IBM SPSS Statistics version 19. Keep in mind that if you're running a different version, there may be some slight differences between them. However, in most cases, the differences are usually quite minimal. In this tutorial, we will discuss 4 topics covered in Chapter 2 of the text. Specifically, we will look at how to use SPSS to create frequency tables, crosstabs, pie and bar charts, and histograms and boxplots. To start, we'll need to open the file Chapter 2 Video Tutorial Data.sav. To do this, we go to File, Open, Data. Then once we have navigated to the proper folder location, we select the file and then click Open. You will probably recognize this data from the Chapter 1 tutorial, but to recap, we have 3 variables: gender, age, and number of text messages sent. We also have 18 respondents, with each row representing 1 respondent. As you can see, the measurement properties for each variable have been set, labels have been applied, and the value labels for the coding for gender and age have been entered. Before we begin with our first topic, it's worth pointing out the Values Label button on the toolbar. By clicking this button, you can view the value labels for each response. You'll notice that the numeric values are still in each cell, but the value labels assigned to the numeric values are now visible. In this tutorial, we will be using the 2 drop-down menus Analyze, which is where we will find various analytical procedures, and Graphs, which is where we will find several options for graphing our data. Now, to create a frequency table, we select Analyze, Descriptive Statistics, and then Frequencies. Once the Frequencies window appears, we select variables that we want to create frequency tables for, make sure the Display Frequency Tables option is checked, and then press OK. SPSS provides us with an output window that contains our results. In the output window, a log of the output generated is provided in the left pane, while the output itself is shown in the right pane. You'll notice that the output window has the same drop-down menus as the data editor window. This allows us to run additional analysis without having to go back and forth between the 2 windows. The first table we get provides us with summary information about the variables that we requested frequency tables for. In this table, we can see that we have 18 valid responses in each variable and no missing data. Next, we have the frequency tables for both gender and age variables, with each row in the table representing the variable's categories. This is an example of where value labels are useful. Had we not included these when we set up the data, we would see the codes here rather than the labels. For example, rather than seeing the labels female and male, we would see the number 1 and 2. Looking at the frequency table for age, we can see that 27.8% of our respondents were between the ages of 20 to 23. The frequency table for text messages sent is much longer than the other 2. This is because the variable has a ratio level of measurement, and therefore each unique response will be listed. As you can see, approximately 44.4% of the number of text messages sent were less than or equal to 43. To create crosstabs, we select Analyze, Descriptive Statistics, Crosstabs. The crosstabs window allows us to select which variable we want in the rows of the table versus the columns. For this example, we'll have gender in the row and age in the column. The first table of this output provides us with summary information about our data. The second table is our crosstab. As you can see, gender is in the row position and age is in the column position. Looking at the results, we can see that we had 4 male respondents between the age of 24 and 27. Now suppose we wanted to add percentages to our crosstab, similar to table 2.8 on page 50 of the text. To do this, we go back to Crosstabs window via Analyze, Descriptive Statistics, and Crosstabs. This time we will select the Cells option, and then under the heading Percentages, we select the percentages that we wish to add. Select Continue, and then OK. SPSS will then provide us with the Gender by Age crosstab with both the count and percentage information. When you add percentages to a crosstab, it can get a bit difficult to read, so it's worth spending a bit of time covering how to read this table. As you can see, we still have gender in the row position and age in the column position. However, this time we also have percentages within gender, age, and total. Let's look at the age category 20 to 23 as an example of reading this table. By looking across the percentages within age for females, we can see that females represent 80% of the respondents between the age of 20 and 23. Likewise, males account for 20% of the respondents between the age of 20 and 23. In the total area, we can see that the percentage of those in the age category 20 to 23 add up to 100%. Now let's look at the percentage within gender values. Here we can see that of the total number of female respondents, 18.2% were between the age of 24 and 27. Similarly, of the total number of male respondents, 57.1% were between the ages of 24 and 27. Finally, of all respondents, 33.3% were between the age of 24 and 27. Now, on to our third topic, pie and bar charts. There are a couple of ways to obtain these charts. One is through the Frequencies window, where we asked for the frequency table. By selecting Charts in this window, we have the option to request bar charts, pie charts, and histograms. Another way is to use the Graphs drop-down menu by selecting Graphs and then Legacy dialogs. Under this menu, you can select a range of different graphs. The first one we will create is a pie chart. By selecting Pie and then choosing Summaries for groups of cases, we will be given the option to select the variable that will define the slices of the pie. We'll select Age and then press OK. Now, in the output window, we see a pie chart of the variable age. If you wish to customize a table or a graph, you can do so by double-clicking the object inside of the output. Now, to create a bar chart, we go to Graphs, Legacy Dialogs, Bar, then select Simple, and press Define. To define our bar chart, we need to state what variable we want on our category axis, which is the x-axis. We'll select Gender, and then click OK. In the output window, we now have a bar chart of the variable gender where we can see that our dataset contains more female respondents than male respondents. Had we selected age to be the variable for the category axis, our bar chart would have looked like this. The final topic we will cover in this tutorial is how to create histograms and box plots. To create a histogram, we go to Graphs, Legacy Dialogs, Histogram. We then select the variable that we want to plot, which in this case is number of text messages sent. While we won't use this option in this tutorial, you can see that we can overlay a normal curve on our histogram. We'll come back to this option in the SPSS tutorial for Chapter 5. By selecting OK, we can see the histogram of number of text messages sent in the output window. The x-axis provides the number of text messages sent and the y-axis provides the frequency. We can also see that in this histogram we have 7 intervals, or more specifically bins, that are used to describe the data, with each bin labeled in increments of 20. But suppose we wanted to change our histogram to say 4 or 5 bins, with each labeled in increments of 10. To make this modification, we start by double-clicking on the histogram in order to bring up the chart editor window. To modify the properties for the scale on the x-axis, we double-click on one of the numbers on the x-axis and then select the Scale tab. Under the Scale tab, we then change the major increment from 20 to 10. Then press Apply and Close. You can see that our histogram has now been updated. Now to change the number of bins in the histogram, double-click anywhere on the bars of the histogram to bring up the Properties window. Select the Binning tab, select Custom, change the number of intervals to 5, and then select Apply. You should now see that the histogram has been updated to include 5 bins. Changing the number of intervals to 4 will result in 4 bins. Lastly, to create a box plot, we select Graphs, Legacy Dialogs, Box Plot, and then choose the Simple Box Plot option. Next, we select Number of Text Messages Sent as the variable for the box plot, Age as the category axis, and click OK. In the output window, we can see that we have 3 box plots of the variable Number of Text Messages Sent, separated by each category of the age variable. Similarly, had we selected gender rather than age as the category axis, we would have a box plot that looks like this. This brings us to the end of the SPSS video tutorial for Chapter 2. We hope that you have found this tutorial useful. In the Chapter 3 SPSS video tutorial, we will concentrate on using SPSS to obtain measures of central tendency, dispersion, and shape.